Good afternoon to all participants present here. Good afternoon to everybody. Am I audible?
Yes, sir.
Okay, fine. So now I request my co-coordinator, Dr. Sushruta Misra, who will introduce the speaker of present session. So Dr. Sushruta, please proceed.
Yes, sir. Thank you very much, sir. Good afternoon, everyone. I am Dr. Sushruta Mishra, School of Computer Engineering, KIT deemed to be University. We'll have a second session now. This session basically addresses the role and impact of AI in 2D medical imaging. Various vital aspects related to this topic will be discussed, and we have with us our industrial expert, Mr. Sunil Kumar Kar, to lead this session. Mr. Sunil has completed his computer education from BPUT and have worked in several MNCs before. He is very well equipped in multiple programming skills like Java, Python, Android applications, etc. In research domain also, he has handled various multiple projects based on artificial intelligence, education domain, healthcare domain, using computational intelligence for various construction projects as well. He has received entrepreneur awards from several educational organizations also. Very passionate and enthusiastic with his work, he is currently the CEO of a developing IT organization, Center of Advanced Software Technology and Solution Private Limited, which is both a service as well as product-based firm. Now I request Mr. Sunil to take over the session and give all of us a deep insight of the topic. Mr. Sunil, please.
Thank you very much for your warm words, sir. And I would like to show my gratitude to Keith and Dr. Susrat Misra and Dr. Uday Kumar for your opportunity and inviting to present here in this session. Am I audible?
Yes,
Yes,
sir.
yes, yes.
Okay. Thank you very much. So, as Dr. Susrat Misra said, we have been indulging and developing applications and based on AI and how it will be useful on the different real-time world. So I will demonstrate what exactly we have done. I will basically show what exactly we have done. But prior to that, sorry, prior to that, so let me share my screen and explain. As the session is all about AI and 2D medical imaging. So let me start from the beginning. What AI and what are the different other domains or industries where AI can be applied, and what exactly we have done as an industry, what we have done, where we have implied we have used AI to solve some of the real world problems. So that we will, so then basically we'll see how AI can be useful in medical imaging. So let me share my screen first. Oh, it is visible.
No, Sunil, it's not visible. Okay, fine. It is visible. It's visible.
Thank you. So before getting into AI and 2D medical imaging, let's start with AI. Excuse me. Let's start with AI. What exactly AI is? So AI basically On this session, what I will basically address is AI and its different branches. Is we know AI.
Hello?
Am I audible?
Yes, yes. So AI individually will not be useful in the industry. Along with AI, we need some of its branches which will come together to make things useful. So we will discuss what is AI and its branches, then different use cases of AI, some of our implementation that I'm going to show you that what we have implemented, how it is useful, how AI will be useful on our implementations, some of the examples. Then AI and 2D medical imaging, what is the impact of AI, what is the advantages, how AI will be useful, what is the disadvantage of AI, that I will be going through. Then is the hype is all about AI. So will it replace the doctors in medical imaging? When we talk about will AI replace the doctors? That we will discuss, and I will show you a small example that which I will run here, and I will show how it is being executed. So first of all, what is so when it comes to artificial intelligence, as we said, intelligence, it's a branch of computer science through which what we want to do is we want to create a machine which can think, which can work like or better than a human being, right? So we want using AI. What basically people want to do? They want to develop a machine. They want to develop a machine which can think, which can act, which can work like a human. Like whatever situations comes up, how human tackles the situation. That's the same thing people want to achieve through AI in a machine. So as I said, AI alone cannot do all of it. Is some of its branches. So AI will work with some of its branches to come across to solve real world problems. So what are the different branches that we are talking about? So as I'm showing here, these are the different branches that AI has. Along with that, as days goes on, some other branches are sorry, excuse me. As days goes on, some of the branches coming and get added into the vast top. So as we are saying, through AI, we are going to develop a machine which can think like a human. So that machine needs to do everything that a human can do. So for example, so what a human can do, we want to achieve intelligence in the machine as of a human. So human intelligence is not the only thing which will work along with intelligence. It needs the different actions. It needs different parts of the body to its intelligence, right? So similarly, here also in AI, we need that. Like for example, a human can speak and listen. To represent that action of human, we have the speech recognition. Speech recognition using what we can say, we can tell a machine, we can tell the machine, we can tell a phone, car, everything, we can tell something, and we expect some actions beyond. So like humans speak and listen, that speaking and listening action can be performed using the field of by implementing this field of speech recognition. Similarly, a human can write and read. The actions of humans, like reading and writing, can be achieved through NLP, natural language processing. So using natural language processing, what we can do is we make a machine understand, read, write. Those things can be achieved through natural language processing.
and this speech recognition and both are statistical based. So these are these are depending upon some of the statistics. So we can also call them as statistical learning. We can also call them as statistical learning. So like the other, like human can see and process things, like a human can see and creates images, processes things in his mind. So that we can represent as computer vision. Computer vision is a field of AI which will work as watching and processing acts of human. What a human can do. Computer vision also a part of this symbolic learning, because in computer vision what happens, we give symbols, we make the machine understand the symbols and act according to the symbols. So this is basically part of symbolic learning. I'm dividing this AI, basically we will divide AI into two different, that is, one is symbolic learning and machine learning. Why exactly learning, that I will come across. But here that can be represented as computer vision. Then human can recognize, and after recognizing.
Mr. Sunil, can you share your slides, please? It is disconnecting, I think.
Oh, okay. How about now?
It's not yet visible. It is under processing. Yes, now it is visible.
Okay, thank you. So similarly, the other thing is human can, and the human eye can recognize and act accordingly, right? So human, when human watches a thing, what human does, it recognizes and creates an image on his brain, creates an image of that specific object on his brain, right? So that creating an image, that can be achieved through the field of image processing. And the other thing, like human can understand its environment, like when we work, if we get an object, we just get aside and we work in a different way. So what we do is we use our intelligence by understanding the environment, we move ahead according to the environment. So that can be achieved using the field of robotics. Like again, so here what we say basically, again, what human do, human understand the patterns, human understand the patterns, human can group different people, human can identify, human can use his intelligence to differentiate male, female, it can group people. So that grouping of people can also be achieved. Excuse me. That can be achieved using concept of pattern recognition. So using pattern recognition, basically this pattern recognition, machines can do much better than humans. Machines can take out of data in a very less amount of time. They take data, they learn from the data, and they recognize patterns much better than humans. So this can be achieved using the concept of machine learning, referred machine learning. So here, using machine learning, we can basically feed human, we can feed the machine to recognize patterns, to recognize objects. So we can do that using machine learning. So I will come to machine learning after some, like this. Now human does all this with the help of his brain. So that brain is a network of neurons. Human brain, what basically we say, is a network of neurons. So to implement that in a machine, so implement that through AI, we have the concept of neural networks. So in neural networks, so what basically happens, it is like human brains. We can create network of neurons here. What basically the neural net will help us to make the machine work the way how human brain works. And if the network is much deeper or network is complex, then that can be accomplished using the field of deep learning. Using deep learning, what we can do, we can achieve the same thing that the human brain can. Like if we want a human brain to understand objects, to scan objects in a specific direction, and after scanning the object, to identify the objects. So for that, we will use this CNN, convolutional neural network. So basically using this, it is used to recognize objects in a specific pattern, in a specific scheme, in a specific sequence. So that is the use of the CNN. So and the next, like what we had for lunch, every human, most of us will remember what we had for lunch. So human brain remembers things, and we can make machine to remember things using a concept of excuse me, using a concept of recurrent neural networks. So these are the different fields of AI, which is basically conceptualized by looking into the actions and behaviors and properties of a human being. So we do all of this, and AI uses all of this to do two things. Basically here, AI basically does two things. It learns, basically AI learns things, and the learning of AI can be in two ways. One is the symbol driven, using symbols AI learns. The most important one is data driven, where most of the world stops. So data driven. Here, what will happen in data driven, if we get, for example, in a company, if we get a data of the amount we are spending and the amount we are getting. So if we get data, so what we can do is we can basically we can basically patternize this to understand and move ahead. So basically we will get the data, we will plot something, we will work data in a different, we will work with the data in different dimensions, and we move forward and we will plan our next actions. So that can also be achieved using AI through this concept of machine learning. In fact, humans can basically decide by looking into one or two dimensions or three dimensions. But once machines learn this, machines can do in multiple dimensions, and the results that machine can bring in, that can be maybe human may not touch that result. So this is what really people want to achieve from the sorry. So machine can do this. So all this AI, whatever we implement, this we are implementing to do one or two basic tasks. Like what are the tasks that we are going to achieve? One is classification. The other one is prediction. Basically, classification in the sense we are classifying for in a company. The business intelligence, what we call, they are spending amount and what is the return they're getting out of it. The sales team, if they want to track it out, so they will basically classify the customers, maybe on the basis of gender, on the basis of age groups. They will classify the customers and then to understand the interest of the customer. So this can be done easily using mechanics. And here, machine can do much better as compared to that of human beings, these classifications. And on the basis of the classifications, what we can do is we can come up with the predictions. So in predictions, basically predictions in terms of on the basis of classification result we are getting, we can predict what the customers like and what location customers need what. That is the reason why this e-commerce is getting more famous and famous. The different we can classify products as per customers. So these things can be predicted easily using machine learning as compared to that of a human. This can be done very easily as compared to that of human. So again, on machine learning, so all these things is possible. Machine can do all these things. Excuse me. Machine can do all these things if and only if the machine gets trained. We need to make the machine learn things. So we need to train the machine. So to do that, basically what there are different ways of training, or there are different ways of learning. Basically, we classify them into supervised learning, unsupervised learning, reinforcement learning. Supervised learning, basically, it is a type of learning or training where the given data consists basically the output. We exactly tell the machine. We make the machine understand a pattern, and we just make them guess another pattern that we are giving them. That is basically supervised learning. Unsupervised learning, we won't basically tell the machine the patterns. We want machines to find out the patterns in it, what kind of patterns that in the data is, what patterns the data is. That we are basically, we want the machines to do. And in reinforcement learning, what we are trying to achieve is we are just telling the machine act according to the situation. Machine will act according to the situation. That's what we are expecting. So this is what basically the different this is what different branches of AI, and using what we want to achieve those things. Like the, as I said, speak, human can speak and listen, and here the machine will do the speech recognition, natural language processing, all this what I've explained. So you use case of AI ML. What are the use cases and what are the different industries where AI can be used? AI can be used on construction industry. AI can be used in marketing. AI can be used in social media, healthcare, pharma, travel industry. There are a number of industries that AI can use. Consider travel. If we consider travel, where this AI and ML will be helpful, ML will be helpful finding the dynamizing, predicting the days in the flights that done through in the travel industry. And if we consider some other like marketing industry, in marketing industry, what to do, we can predict the customer, the location of the customer, where the product gets sales more, so upselling, costing, all things we can do using on marketing, right? Again, in social media, the concept of this marketing. Sorry. So as I said, in healthcare and in social media, basically, what are the different things like digital marketing? Digital marketing, most of the people now adopt this. So I as a company, if I want to sell my product, so I want to make this product reach the goal. And this was not that easy prior to this social media. So that can be achieved quite easily. So in digital marketing, Facebook, Insta, all other social media platforms.
Please share your slides. Share your slides.
Oh,
I think internet is also slow, perhaps. So lot of disturbance. So anyway, we'll manage with that.
yeah, it has some issues.
Okay.
And yeah, the situation is like this that I can't do anything more about it.
Yeah.
Sorry. So I was saying, this is still marketing. So we use AI ML here to basically target customers. Like previously, when we need to make a product release ago, it was quite expensive, and physical market usually is expensive.
Sunil, I think you have an internet issue. Perhaps it is frequently disconnecting.
How about now?
Now your screen is not safe. Voice is breaking.
Okay. How about now? Is it okay?
Okay, what's your screen? You may share the screen, please.
Did again. Yeah. Excuse me.
Hello.
Is the screen visible?
No, not yet. No, it's not visible. Hello, Sunil.
Yeah.
No, your voice is totally breaking. No screen is coming.
Is it okay now?
Have you shared the slides?
I did. I did. God.
Yes, it's visible.
Okay. Okay. Yeah. Thank you. So, like as I was saying, basically we can use AI, ML, and different. We have it in one of the industry which is being practically implemented. Let me show you. So this is one of our implementations. What you do, basically our clients share us the videos. This application is being used in some of the counties of US. So we have implemented in Rio Vista, one of the county of US. So what basically does happen here? So we have created a web-based program. So what is the use of that program? It takes a video as input and it gives the output. So what happens in the video? So I will show you the sample video, input and output video. So here the goal of that is to identify signs on the road. So basically our output program, which is a Python based application, what it does, excuse me, what it does, it takes the video with the sign as input, and it displays this output by identifying the signs on the road. Along with that, we have implemented for cracks. so the application is intended to take a video of a road and identify the roads with cracks. So along with tracks, we give some other inputs. So let me show that video basically. Is it visible? Is the video visible?
Yes, yes.
Okay, so this is a sample video. I have the basic size of the video will be half an hour, but I just for the sake of showing it, I have just put it to a 20-second video. So let's look into the video. So this is the sign. This is one sign. The goal of the video is from the video itself we need to identify what are the signs that we have on this. So this is one. There is other sign like stop sign. So this we need to identify. And another one is the speed limit 25 sign. This also we need to identify through our program. So this is what the task was. So once we input this video to our program, so our program gives this. So here you can see a green box coming. Excuse me. A green box surrounding this. So here this our program identifying identifying the sign. Again, for some other sign it will do the same. So here the stop sign is also being identified. You can see a border around it. So that border basically says the stop sign identifies it. Okay. Again, along with this output video, we give the client some other information like at what lat long the sign is and what is the sign, all those things. You can see this is a box coming up which identifies. So this is the program which is being implemented and which people use there. We just do it to do the sign, and I will show you some other video which does for the cracks. This is the input video. So this is the video of the road. What it does, they give this as input to us, to our program, and what we do. And this is our output, which is so these blue marks. So these are basically the cracks it is identifying. I hope it is visible.
Yes,
So what our program does, our program identifies these as crack. So along with that, so here some of the information I'm displaying on which frame number it is, what is the latitude, what is the longitude, and the crack density. What is the density of the crack? And we put some of the formulas to prioritize the cracks, and we send it to our client. So then, according to the report, and they can identify. And to be honest, the accuracy of this program is still not up to the mark. We are still working on to make it more accurate, but this is what some of the things that we have done on the industry of this. So what to do this, like as I said, how this machine works on it. To do this, we have to put like the signs. To identify the signs, we prepare a data set. We prepare a data set like this. So this is the data set. We create this data set, which using the data set we will we train our machine. That machine sees this data. Sorry. Machine basically gets the data. Along with the data, we take the images from Google itself. We give a XML, and the XML file I can show you here. What we tell on the XML file, we tell the size, basically size of the image 200 and 200. And here, what is the name of the image? The school sign. This is the course that in US they have. Then here, exactly at what coordinates, what XY, this is exactly the sign is. So here you can see the sign is not exact to that. So that we basically give through the through this XML. So what machine does, and our algorithm, how this algorithm works here, we are taking a image size of data site sample size of 25, sorry 250, which is not enough as per the standard. It's not enough. So we have algorithm. What that algorithm does, it converts and here this we does two things with these images. After taking it to, after giving it to the machine, our algorithms does two things. Excuse me. One basically the algorithm converts that image into different resolutions, because when someone goes in, the signs may be of an shade, an array, in the resolution of the sign will be different. So by looking into that, we have algorithm which converts the signs sign resolution. The second what we do is we create at least 20 different images from every individual image, and now each image will go through a regression of maybe 20,000, 30,000, and that we set that we set. So here what will happen, a machine gets learned through this science, and after learning we give these videos as input and it gives that output to us. So this is one of the implementation that we have done through this AI ML. This works. The accuracy is not up to the mark, as I said. The training takes a lot of time, and again the detection also takes a lot of time, and me and my team are working on it to make it correct. So this is one of the implementation, like some other are there. So now when it comes to as per the topic, when it comes to medical imaging, right? So what is how AI will be helpful in medical imaging? A number of people has implemented AI and some other platforms. Excuse me. Implemented AI and different platforms. Now it's time people are experimenting AI on medical imaging. So in medical imaging, imaging, what exactly this is in 2D imaging? As we know, most of the diseases doctors find out through X-ray, ECG, all those reports. So the plan is to give an X-ray as an input, and let AI predict the output. Basically, whether that let us consider a bone, a fractured bone. We give input a fractured bone, and we expect AI to give whether the bone is fractured or not. If fractured, what is the highlight of it? So where exactly it's fractured? So that is what being basically expected from a AI. So as I said, the deep learning and machine learning AI has been used in non-medical imaging. I have shown you some as well. So right now it's time to make this AI useful in the sorry. So what are the different images that medical images that we can give as an input as per the work? This X-ray we can give, this mammography we can give, digital pathology. Then this 2D images will be useful. The 2D images will be we will have a sample data set. We have to give a sample data set to this for this machine learning. Using the data set, again AI machine will predict depending upon the status of that specific X-ray or disease. Like as I said, the bone. So if something is there, then it can predict whether this can be whether this is fractured or not. That can be predicted through yeah. Sorry. Yeah. So what are the different AI implementations as it is? So one is this medical image analysis. Here, this can help identify different anomalies, differentiations, and diseases based on the medical image better than doctors. So that is basically one of the technique through which what we are going to do is we are just going to develop some algorithms, develop a machine which can take input of X-rays and display different outputs to do a better prediction, right? And AI can also be in the field of medical science, medical imaging. For AI can also be implemented for diagnosing different neurology conditions through again different neurology. It can help doctors to diagnose the neurology diseases, and recent studies said AI study has also shown that AI was able to predict Alzheimer's disease. This is the type of disease here before the manifest, means when the disease starts. Before that, basically AI can predict that. Okay, we can tell all this, but still it's not fully implemented and proven. So these are the conceptualizations where people are working on it. Like again, AI can be implemented for identifying and revealing different cardiovascular abnormalities, like from an ECG, it can identify basically what is the heart condition at this present. And you all might have known that a recent article, and the CEO of Apple also tweeted that the Apple Watch has saved a life of a 61 years old farmer patient. So basically, how this happens, using the Apple Watch, which uses again the AI to understand, to monitor the ECG, the heart condition regularly. So when he felt unwell, so he basically monitored his ECG. Then based on it, he sent the report to his doctor, and on the basis of his doctor told him to basically do a surgery, and he is alive. So and you must be knowing that Tim Cook has tweeted on it for a speedy recovery. So this is what AI can bring in. Basically, this can give timely reports through which what will happen. We can basically save lives using what we can solve the problem. We can basically cure the diseases before it gets serious. Like the other implementation, you can use AI for cancer screening. Basically, we all know cancer can be diagnosed well if we know it well in well advance. So basically, scientists are still working to create AI-based CNN, which will be used to identify the cancers at different stages like 1, 2, 3. And the report says high, sorry, they're highly successful on understanding this, getting this. So what are the advantages of AI you can get in the field of medical image processing, medical image processing? Like the first benefit of AI is a lot, but using AI, the reporting will be much faster. As the first of these includes increased productivity due in part to absent of need for natural breaks in 24-hour day. So basically to get a report and to tell a doctor, a human cannot work 24/7, right? So when we take a report to a doctor should be available, doctor understands, and doctor gives the report. If that can be replaced, using AI, it would be a huge success. And that's the where scientists, programmers are working on. So basically this will result speed recovery, and it will increase the productivity of doctors as well. Like as I said, the advantage would be humanistic implementations, lack of humanistic implementations. Like as I said, humans cannot work 24/7, but we can make a machine work 24/7. So here, the inputs we give to the machine, and if the machine predicts the output age of a doctor, then that will be basically useful, and it will replace various biases like of knowledge, clerical errors, some writing mistakes, reporting mistakes. These can be avoided. If we may not be avoided, but we can reduce this using AI. Sorry. Again, the other thing is the cost can also be reduced. Like the other hospitals and institutions, like they buy graphics processor, imaging software. This cost is there. So if machine can take this, and if we can replace this using AI, that cost can also be reduced. Sorry. The other thing what AI can do is the AI can help hospitals to build different marketing strategies. Basically, market their things, like each and every hospital. They do marketing products, but AI can help in a much better way to market products. So these are some advantages. Along with this, AI, there are different disadvantages with artificial intelligence as well. Like a machine may not predict things 100% correct. The disadvantages of AI was this algorithms and softwares may be able to compete for existing human levels. So that would be basically a more cost-effective way. So hospitals want to reduce the human employment is human employments over the time. So that might be one of the disadvantages, but not big. The second, the personal connection of reviewing an image will continue to be necessary component of radiology. The radiology is one of the field of medical imaging. So here basically the errors that AI makes, that always requires a human convention, because we can, at this point of time, we may not tell about the future, but at this point of time, there is no machine which is being developed which will give no AI machine which is developed which will interpret 100% correct. So human interpretations will be there, and if some mispredictions may lead to human losses, so that we cannot afford that risk in this case. The other thing, basically, after basically people do trust the doctors. After surgery, they connect with the doctors, they have a personal connection with the doctors. If you replace AI with this, that will not be there, and the patient's trust factor may get also be impacted through this. Like now the key reasons why we basically say AI will not replace the radiologists or the doctors. And this is not the first time this computer aided technologies has been we are implementing. So earlier also, since 90s, people are implementing this, but it is never that you can take out without a doctor. So basically, the earlier study also says, researchers says that like a radiologist, he can see a report. Along with the report, he can think of some other things, some other 10 other things through which he will basically suggest the any of the radiologists will suggest the cureness, right? How exactly to cure that disease. Not only that, he will think of some other things. But the way how AI may give report is it can see only one dimension of that, and the other dimensions of a human it may miss. So that would be one of the problem. Then another key reason, we cannot say an accurate algorithm is equal to an accurate radiologist. Never. So we cannot say that, right? So a algorithm cannot be equal to a radiologist or a doctor, because the algorithms may fail in some of the cases, but radiologist will use its own basically skills, experiences. So that may be one of the reason. So basically here, as I said that the same point, an accurate so algorithms that can help diagnose common conditions are major step forward, but a radiologist is looking for numerous conditions. As I said, a radiologist can look into think of some other different conditions, but a algorithm will only think of in a single dimension. So that may not give a satisfactory result. And after all, basically, even people said the autopilots will replace pilots, but it didn't happen. It didn't happen. Autopilots never replaced never replaced the pilots. Autopilots, what autopilots can do? Autopilots can help pilots to make things easier, but autopilot cannot replace a doctor. So similarly, when it comes to will AI in medical imaging will replace a doctor, radiologist? The answer, what we think, this answer would be no. So in other way, what we can do, what we can say is a radiologist using AI can replace a radiologist without using AI. That can be quite fruitful, but it may not be true that a radiologist will replace. Okay, so as I said, the radiologists who AI is we are lifted by the latest AI bubble. Will AI replace radiologist? Is this is the wrong question. So what if we can say is the right answer is radiologists who use AI will replace radiologists who don't. So basically, people doctors definitely should use AI. It will take the help. They should take the help of AI to make things more productive, to make things more faster. But AI will not replace a doctor as of now. So basically, so the sentence is the right answer for this is will AI replace radiologists? So that will be radiologists use AI will replace the radiologists who don't. So basically, I have a simple example I have plotted here. So what exactly I'm doing on the example? It's a very simple program that I have given. As we do not have more implementations on medical imaging as of a company, at this point of time we do not have more implementations as a company. So I have done a very small program to show what exactly this is. So the
Sunil, are you okay? Hello. Hello. Sunil.
Is it visible?
Yes, it is visible.
Yeah. Thank you. So
Are you okay, Sonal? Can we proceed?
yeah, I'm just trying to wrap up. I will just run a program, and I'm trying to wrap up as soon as possible. So so basically what we'll basically show here is we will input. I have a very simple program. So what this program will do, it will take a scanned copy as input. It will take a scanned copy as input. I mean this X-ray copy as input. Then basically it will give some of the outputs like this. Basically what we do is we are just making a threshold value of it. And the program is all about sorry, to identify if there are any fractures on the bone or not. So this will give the sample output. I will explain later on. So how exactly, what is the process that we are implementing here for the bone fracture detection? The first thing is we are just doing this image pre-processing. So what image pre-processing again? Training the machine. So the predictions will not be 100% correct about, but I can show you what exactly I have written here. The first thing was image pre-processing, and image pre-processing, I take the sample
Sunil? Hello, Sunil, are you there?
sample images.
Yeah. His voice is breaking actually.
How about now?
Now it's okay. Now it's okay.
Okay. So so like image pre-processing, what exactly I'm doing. Give me 1 minute, please. Please.
Take a little water, please.
I'm doing that. Please give me 1 minute. Sorry, sorry for the inconvenience.
No, it's okay. It's okay. Thanks to you that you are keeping your commitment and attending your duty. So, thank to you.
Thank you. But yeah, please give me 1 minute. Okay, so on the thank you. Yeah. The image processing we do here, we take some of the images to train the machine, and here what we again do, we make the X-ray convert. Like we make the background X-ray dark, and the bones whichever on the X-ray that we make like that will help identify. So basically it help identifying the machine, the bones, and the part of bone except the bones. The machine will identify like this image I can show. So here, like this is the grayscale one. So this is the converted one. So here the except the bones, the other parts are basically Note this bones are lighter side and the dark side. So this
Your screen is not coming. Sunil, your screen
is
is
not.
not coming and voice is completely breaking. Yeah, I think it is a internet issue at your end. So please
Yeah.
check the log. Yes, now it came.
Is it visible now?
Yes, it is visible.
Yeah. So this is in pre-processing. We're just trying to do this. So we are just converting the background to black and are white. So I'll quickly run the program. So here again we do the clustering of images. Similar images, we categorize them. These are part of the training. We put images into different clusters so that it will basically identify.
Your
Then
voice
again
is
we class.
totally breaking, Sunil. Not audible at all. Your voice is breaking. Could you please
Okay.
do something for your signal? Can you please change position change where the signal you will get more signal?
Yeah, I can do that actually.
Yeah, I understood. I understood your problem. Okay, you try your best.
Yeah, is it okay now?
It's okay. You said slides are visible. Slides are visible. Only the voice is not. It is giving much crack.
Okay. Okay. Yeah. So in the clustering, we just put the image of images to one cluster. So this will basically help, and according to the clusters, we train the machine, the body part, hand, ankle. So this basically we train the machine just to identify. Then it will. There are different bone conditions. Again, we classify them to the machine. While the process of training, what we do, we give input different bone conditions, which is a good bone, I mean, which is not break-in, which is break-in, what is the percentage of the breaking point. Those classifications we basically give it to the machine for the purpose of training. So machine gets trained with this. Sorry. Then basically it search for the matching images. So whenever we input a bone, now it's about the detection. So whenever we input a bone, so basically it'll previously, on the basis of the previous three steps which are part of training. So what basically happened, whatever it is trained, accordingly it will find out the matching images, which whatever trained images machine has, it will match with the images. If any match is found, then it will give the report. Then it will overlay of images. Basically it will do the overlaying. Just also part of, sorry, which is basically also part of. So basically part of detection. So here it will what it will do is it will basically compare the base bone with the input bone, and it will do a overlay for the comparison. Then on the overlaying, whichever match is finding on the match, it will do overlay and it will put that image, you can say. Then it will try to find out the irregularities. If with a good bone, if I, for example, if I give input of an ankle, so it will try to find out what are the images it has trained, which is similar to an ankle. So once it will find out the best match of ankle X-ray, then it will overlay the input image, input X-ray of ankle, and the ankle it's got trained. Now it will match. Then if any irregularities find, it will highlight the irregularities. Then it will generate some of the analysis report. And this is what basically I've done. Let me run the program so I can show you that out here. This is the whole slide. Before executing it, let me explain the background of it. Here are some of the images. So basically, these are the fractured images that I have here, and with some of the libraries I have given the training. I have given a good image and a bad image. I mean a broken image where it'll basically help the machine to identify. So let me, for example, let me run this f2.jpg. This is the image. So f2.jpg, this is the image, which is a broken X-ray. So let's see what it does. So here on the program side, I have this. Okay, I have F12. Let me do it F2. As I said, this is not a use. I have not created the user interface for it. This is a very simple Python program. The image name I have given. So I have given the path. I have hard coded the paths here. So where basically it takes the resized image for F2 and fracture bone for F2. Now let's basically run it. For F2, I am doing it. So here is the first output. This is the input that I have given. So here is the output. It says the image has been, the background has been taken out. It's completely dark, and the bones, the bones are purely white. This will help it to identify over in an overlay. So this is the report that we are getting out of it. The report. So here you can see it's identifying. As I said, I have not trained the machine with a lot of data. It's identifying a lot of them, but you can see here, these are the identifications of it is doing. It's basically the identifying the broken parts, and some of the parts also like this is also, it is thinking is a broken bone, which this is not. As of when the training increases with more and more images, this will get accurate. So this I have created for a demonstration itself. And now the next thing is here I'm just showing a graph here and a chart. So this chart I will do what it will basically identify the coordinates on which x-axis and y-axis the more fracture is. So this is the axis. So here you can see this is the most fractures is that it will show up, and the fracture part it will show up like this. So and here also it shows the coordinates where basically what is the position where the fracture is more. So this is a very simple program that we have done, which is not exactly accurate. That I understand. We should get accurate as of when we give more training and the things. Okay, yeah. So this is what I'm concluding here. So should I expect any questions from her? Yeah. Should I expect any questions?
Good evening, sir.
Good evening, please.
Sir, one question is there. We are taking the radiographic images, and
Right.
for example, suppose I am predicting the rheumatoid arthritis.
Right.
We are taking radiographic images as well as some other images as a cameraman.
Okay.
And what type of model I have to use? For example, radiographic images parameter, is there anything is there so that my accuracy may be increase or decrease or something is happen? Because medical area I want to do it that work.
Okay.
And so the what aspects we have to consider more whenever we are going for the radiographic images?
Okay. Aspect in terms of the inputs you are talking about. What
Yes,
are the
sir.
different
Yes.
inputs?
Yeah.
So the first thing, whatever you do, the training should be correct. Is ML is more accurate with respect to training. The more training we do, so the training should be correct. Then according to the training, those images, basically whether the image is means fractured image or defected image, that can be found out. So basically the training should be more accurate. Excuse me. So the whatever here the most important thing is the data. Whatever input you are giving, according to the input, the machine should have trained with that similar type of data, then only it will predict. Otherwise machine would not be able to predict.
Sir, can I communicate with your mail after some days once you recover? For
Sure.
some
Okay.
other questionnaires are there. So
Yeah.
I want to communicate with you regarding this.
Not an issue. Not an issue. Sure. We will. Yeah.
Thank you, sir.
Thank you. Any more participants? Do you want to raise a question before Sunil? Anybody, please?
Sir, good afternoon, sir.
What happened?
Sir, what type of algorithm you have used in Python, sir? That that's a classification program.
Yeah.
Okay. Yeah, use the CNN techniques. Are there? CNN.
Yeah. No. You're asking about which one? On the bone fracture.
Yeah, bone fracture, sir.
Yeah. This is simply just what plotting. It's not a huge algorithm. It's a small that I have done. So it's somehow like small Indian technique. And here basically.
Excuse me, hello.
No.
Can you explain the objective of the graph? It is not clear to me. What is the objective of that last two graphs?
Hello. Mr. Sunil, are you there?
Yes, sir.
Yeah. Can you answer the question from our participants? Hello.
My question is, can you explain the graph, the last two graphs that you plot? What is the objective and what information we are getting from there? I think he lost the connection.
I think he's lost his connection. Okay, sir, no issue. Tomorrow also he will join with us. So if you don't mind, you can put your question. So before him tomorrow he will be with us till the end of the program.
Okay,
So
no issue.
no issue, sir, because today he is feeling a little bit uncomfortable.
Yeah, we understand.
Sir,
can you please share the PPTs of this?
Yes. After completion
so
of
that
the program.
so that tomorrow, if any questions are there, we can ask.
Today evening
Okay.
I will share. Today evening I will share it.
Thank you, sir.
I will collect it and I will send. Don't worry.
Thank you very much.
Definitely, I will do it. So I think we'll bind up for this session, today's session here. So at 4:30, we have an inaugural meeting, a small meeting of 30 to 40 minutes, not much more. So I request all participants, please join in the inaugural session at 4:30 positively. So our university and chief guest from IIT Guwahati, he will be with us. So at 4:30, my request to all of you, please join in that inaugural function. This link is only will open. So till end of the program. So no need to go for wait for any other link or any other invitation. So this is already open. So anytime you can join at 4:30. So for now, we'll stop the session. And Mr. Jaiprakash, please pause the recording, stop the recording.